students. So let us start with an example. What is experimentation, or how we can draw maximum conclusions, and that also correct conclusions from an experiment? Okay, if you know that in the previous era, the world believed that the earth is square. Afterwards, some scientists proposed that earth is not square but it is spherical. And because of this conclusion, the scientist was thrown out of the religion. He was thrown out of the church. Though he was a priest, he was thrown out of the church because he was teaching against the religion. In religion, they believed that the earth is square. So sometimes we are not interpreting the observations properly, and that is why we may end up with the wrong conclusions. So this is the best example. Here there is a picture of elephant. Now if you ask 10 or 12 blind person to describe the elephant by only touching the elephant once or twice, so how will the person describe the elephant? Okay, so the description will be different for different person. When a person touches the teeth of the elephant, he will describe it. It is a like a sharp spear. If it touches its trunk, it will describe it. It's like a python. If it touches its ears, it will describe it like it's a big fan. If he is touching his stomach, he will say it's a massive wall. If it touches his legs, he will explain that it is a trunk of tree. Okay, so from different perspective you can get different results. You might have seen one image in your WhatsApp as well. A letter 6 or 9 is written and two person are standing in opposite side arguing. One is saying that it is 6, another is saying it's 9. Okay, both are correct, but as they are viewing from a different angle, they are getting different observations. In any experimentation also the same thing happens. If you are observing from a wrong angle, you will end up with the wrong result. So the better perspective is to observe from a correct angle. Let me give another example of a failed experimentation, or we can say drastically failed experimentation. I can prove that frog hears by its legs. Is it true, students? Frog hears by its legs. Agree? Come on, students. If you are not speaking, I think you all agree. Does frog hear by its legs? Yes or no? It's a simple answer. Come on.
No, sir.
Does frog hear by its legs or not?
No, no.
No.
No,
Okay.
sir.
So I can prove it. Simply, an experiment is run. The frog is placed on a table, and we tap or we make a noise using any device. So frog jumps. Then we cut one leg of the frog, and again we make noise. The frog jumps lesser than the previous. Eventually, we cut all the legs of the frog, and then we make the noise, tapping noise. But frog doesn't jump. So it proves that frog is not hearing, not listening to the voice, and that's why it doesn't jump. Agree? So if you are designing your experiment in an improper way, you may end up with the wrong conclusions. So before designing your experiments, you should make sure that you are designing your experiment properly and you are analyzing the proper response, the correct response. You should not analyze the wrong response. Okay, so with this, let us start with the experimental designs. Sir Ronald Fisher and Professor Frank Yates, who worked together at the Rothamsted Agriculture Research UK, they defined experimentation as the investigation of a defined area with a firm objective, using appropriate tools and drawing conclusions that are justified by the experimental data so obtained. So there are four parts of experimentation. First thing is, it is the investigation of a defined area. First, you need to identify your problem and then you need to work on that. Second, you should have a firm objective. What you want to conclude from that experiment, that should be clear in your mind. Third one, using appropriate tools. How you will assess it. That is, by designing the experiment and using the tools which are required to analyze the data. And then you need to draw the conclusion, and your conclusion should be supported by the data which are obtained from the experimental results. Let us take a current example. Number of studies are going on at present on the COVID, and the medical practitioners start using the drugs. If you recall, in initial phase of the COVID, one drug was considered as a wonder drug, that is hydroxychloroquine. So many practitioners tried using this hydroxychloroquine and tried curing the patient, and they proposed that hydroxychloroquine is effective in curing the COVID. Later on, they came to know that it is not as much effective for treating the COVID. Later on, some other drugs like tocilizumab, okay, they come into the picture, and that is also now proven that it is not effective in curing the COVID. Currently, the practitioners are using ivermectin, doxycycline, Febiflu, that is favipiravir, etc., etc. And the studies will be conducted on these also. And it might be proven that these drugs are also either effective or not effective on the COVID. But it can be only concluded after a perfectly designed experiment. Using a random trial, we cannot conclude that this drug is effective or not. Okay. So your experiment should have a motive, should have the tools to assess the response, and should get the conclusions. And that conclusion should be supported by data. It should not be a conclusion from one or two random incidents. Okay. Now, most experiments consist of measuring the effect that one or more factors have on the outcome of the experiment. The factors which are affecting the experiments, they are called independent variables, and the outcome or response, that is called dependent variable. Our dependent variable depends on the independent variables or factors. For an example, if we add more sugar to lemonade, the lemonade becomes sweet. So sugar concentration is my factor, while the sweet taste is my response. If we increase the concentration of disintegrant in a tablet, the disintegration time will be reduced. So disintegrant concentration is my factor, disintegration time is my response. Okay. So the response or dependent variable, it depends on the independent variable. And we can change our independent variable according to our wish, our will, or but it is based on the previous experiments or the reported data. Now, the research process, it requires majorly four things. First, that is the manpower. Second, the materials. Third, money. And fourth one, that is time. If your experiment is properly designed, then you can take maximum output out of the minimum efforts by consuming minimum material, minimum man, money, and time. And you may end up with the better results. Let us take an example. If you look back to the mobile revolution, at present we all are using the mobile phones. So if you look back to the history of the mobile phones, when they were invented, we used to use the mobiles like Nokia 3310 or 3315. If you look at those mobiles, they can be used as a tool to harm someone. Okay, if you throw it on someone, it will obviously harm someone. So they were very heavy. In simple words, then they used only few features Like you can make a call, you can receive a call, you can send SMS, you can receive SMS, and you can play 2 or 3 games, you can set alarm. Okay, for that only they were used, and they were having monophonic ringtones, as well as they were black and white. And at that time, that is before 15 years approximately, they costed around 6,000 rupees. Now you think, just imagine that paying 6,000 rupees 15 years back. Currently, the value of that money may come around 60,000 rupees. Okay, so you are paying 6,000 rupees 15 years back for a mobile phone which was black and white, which was only able to send and receive SMS, send and receive call, and few games, and it was black and white, monophonic, and heavy. If you put in your pocket, you will get tired after a while. So from that, within this 15 years, the system changed drastically. That mobiles were based on Symbian system. Later on, Java based mobile phones came into picture. Then currently we are using Android mobile phones that are screen touch, they are lightweight, they are having many features, colored, etc. etc. There are n number of features in that. Okay, and currently we are having the camera features up to 48 megapixel or even higher than that. So all this revolution took place only in 15 years approximately. Okay, before that, though, no one was knowing about the mobile phones. Now this was possible because of the designed experiments. What the scientists did is they tried to draw maximum conclusions or maximum modifications with minimum efforts, and that's why they ended up with the quality products. So in any experimentation, you need to take care of these 4 things. Now, the previous approach was the experimentation. You heard very well about the Thomas Alva Edison. He discovered the electric bulb. Now, that is a tale that he tried thousands of things, even his hair, to produce the electric bulb. And at the end, he ended up with the electric bulb. And in a statement, he said that I have not failed 1,000 times, but I have found 1,000 ways that don't work. That is a very optimistic and good uh, conclusion from an experimenter or a scientist. Though he failed 1,000 times, he described that he found 1,000 ways that won't work. And actually, in research, the negative results are also equally important. Okay, again, moving back to the COVID, the scientists proved that hydroxychloroquine is not effective in curing the COVID. So that is a negative result actually, because they ended up in a negative result. They proved that it is not effective, but that negative result is also helpful to the society, because other practitioners will not end up using that drug in curing the COVID, and they will try another alternative. So the negative results are equally important. Clear? Now the previous approach was one univariate approach, one variable at a time. So in ancient time, the scientists tried to change one variable at a time, and that's why the previous experiments were based on the serendipity and intuition. Okay, the gut feeling of the scientist. Sometimes they feel something from inside and they implement. For an example, you have heard about the Kekule. Before Kekule, the scientists were, the chemists were confused about the structure of benzene. They thought that it is unsaturated molecule, but still the number of hydrogens and the carbon is not matching with any of the previously established structure, etc., etc. And at that time, the structures were only believed to be linear or branched, but not the cyclic. So Kekule, he got an idea from his dream that a snake is trying to engulf his own tail, and he thought that the structure may be cyclic, and he then invented the structure of the benzene. So he solved a great mystery only because of his intuition, his inner feeling. So previous experiments were based on that intuition and serendipity. Now these experiments were in which the scientists were only changing one variable, and that's why at a time they were assessing the effect of one factor. But at present, we are using multivariate approaches. So the traditional approach has many limitations. The experiments are random. They are not well designed. They require more number of trials, more time required, and we cannot predict the extension. What will be the effect if we change two or more variables at a time? So they were lacking the prediction. So these are the limitations of the previous experiments, and the number of trials are more. For an example, if you take an example of extrusion spheronization, there are a number of variables which affect the extrusion spheronization process, like the amount of extrusion aid, amount of binder, the speed of extrusion, speed of spheronization, the uh, drying temperature or the temperature of the column, it's the extrusion column, etc., etc. There are a number of variables which affect the extrusion spheronization process. And if you try to evaluate each and every variable independently, the process will become cumbersome. It will become tedious. So the univariate approach will not be properly helpful in solving that mystery. So it's a wastage of time, money, material, and still we are not sure about the output. Okay, so alternative to this problem is optimization. Currently, majority of the companies are using this optimization to minimize the number of efforts and to draw maximum output of the limited number of experiments. So the design experiments are most informative and they are having fewest runs. They reduce the number of trials to minimum, but in a logical manner. They are reducing the number of trials, but not in an illogical manner, in a logical manner, so that they can draw maximum conclusions from minimum number of trials. Then they carry out research in a systematic way, and they identify the characteristics you want in your product. For that, we are using the optimization. What you want to optimize. Now, the literal meaning of optimization is to find out the optimum. Optimum is not the best, mind well. Optimum is not the absolute best, but optimum is the best within the given set of conditions. Okay, let me explain again. Optimum is not the absolute best, but it is the best within the given set of conditions. Let us take an example of a car. There are a number of cars in the market that range from 1.5 lakhs rupees to the millions of rupees. Okay, then the features are different. Safety features, average, comfort, etc., etc., are different. But still, each category of car is more or less equally sold and equally purchased by the people. What is the reason for that? Is it possible to obtain a best car? What will be a best car? Best car, for an example, it may be that it is having the average of 30 kilometers per liter. It is having 5-star safety ratings. It is having good pickup. It is having very good look, and it costs only 3 lakh rupees. Obviously, it is a best car, and if it is available, everyone in the world will try to purchase it. But practically, it is not possible. So, what is required is the optimum. Now, optimum will be different in different set of conditions. For an example, if I'm a salarized person, for me, the maximum cost of the car should not be more than 10 lakh rupees, for an example. So I need to find out the best car under 10 lakh rupees. If I'm a business person and I want luxury in my car, what I will try to do is the car should be luxurious. Money doesn't matter. So for me, the factor which affects selection is the luxury, and that's why I may go for the Audi or BMW or Jaguar or Tesla. So for each and every class of the person, the optimum region changes, and from that region we will select the best. Okay, so optimization is the best within a set of conditions, not absolutely best. Okay, now the multivariate approach is currently used, in which we are changing more than one factor at a time, more than one variable at a time. And this approach is useful to find out the flagship product. flexi product is the most successful product of any manufacturer. If you look at again the car manufacturing industry, from Maruti, they are producing range of the products starting from the Maruti Alto 800 till the Ertiga and many more cars. Okay, but in majority of the market, there few cars are based. For an example, their Desire version, okay, or their Swift version that is based. So that is that flagship product. If you look at the Hyundai, their i10 and i20, at present Creta also, they are their flagship products. You can see these products very easily, very frequently because they are liked by many people, and that product is called flagship product. Now, this flagship product can be developed or devised by changing many variables at a time and keeping in mind the perspective of the consumer, what the people require, and try to accommodate majority of the things. Okay, try to accommodate the majority of the things in that vehicle. This may be true for many other products as well. In any product, there will be some flagship product. Okay, so the design of experiment will help in determining the flagship product, and its goal is to solve the problem, not become immersed in the statistics. Ultimately, it is to obtain the best product. Now, uh, what are the good factors or what can advantages of the design of experiment? So first is it is speedy process, so less time consuming. Second is it is cheap because we require lesser number of experiment, and that's why it is proper utilization of your resources, so it will be cheaper. Then it is accurate and predictable. We can predict the response at the points where we have not performed even experiment. Then it is accepted by the FDA. Currently, US FDA is also insisting to the industries to apply the DOE, or in other words, it can say QBD, that is quality by design. And the industries need to furnish the data related to the experimental designs or quality by design data to the US FDA. Then it is more suitable for complicated formulation or process where there are more number of independent variables which affect the end product quality or the response. So in such cases, this becomes easier because the experiments are well designed. Where there are various techniques of optimization like full factorial designs or fractional factorial designs, simplex lattice design, packet Bowman center composite. We will discuss all these designs in detail later on. Now, for factorial design, let us discuss a few basic terminologies. So, in scientific language, the factors and results both are called variables. Variable means anything that changes. So, factor is also a variable, response is also a variable. The factor is called independent variable, while response is called the dependent variable. Okay. Now, the independent variables, for an example, polymer concentration, or binder concentration, or granulation time, or drying temperature, or mixing time, or mixing speed, etc., etc., they can be your independent variables. While the dependent variables are the response which depend on the independent variables like friability, crushing strength, disintegration time, uniformity of blend, etc., etc. All these are dependent variables. Now, the independent variables can also be categorized in two categories. First, that is significant variables. Second, that is insignificant variables. Significant variables are those variables which are having prominent effect on your end result, while insignificant variables are those which are not having prominent effect. Though they are having effect, but that is not prominent. For example, if you are preparing the tablets, your disintegrant concentration has more prominent effect on disintegration time. Okay, but your diluent concentration has less prominent effect on your disintegration time. So your diluent concentration is insignificant variable, while your disintegrant concentration is a significant variable. Okay. At same time, the variables can also be categorized as the controllable variables and uncontrollable variables. There are some variables which we can control, independent variables, some which we cannot control. For an example, we can control the stirring speed, we can control the temperature of the environment at present, because in industries they are having air handling units or the HVAC systems in which they can maintain humidity as well as ventilation and temperature. But there are some uncontrollable variables. Because of the power fluctuation, sometimes there are chances that the machine speed may vary. Sometimes in animal studies, there are chances that the animal movement which we cannot control, etc. etc. So there are few uncontrollable variables as well. Now, our independent variables may have positive or negative effect on the dependent variables. That is, the independent variables may increase or decrease the response. Again, taking the same example, if we increase the disintegrant concentration, the disintegration time decreases. Mind well. So here, increase in the disintegrant concentration results in decrease in the disintegration time. So it is having negative effect on the response, because as the factor increases, response decreases. So it is having negative effect. At the same time, if we increase the binder concentration, the disintegration time will increase. It will be delayed. So binder concentration has a positive effect on the disintegration time. Clear? So our independent variable may have positive or negative impact on our dependent variables. The dependent variables, they are also known as response variables. It is output of our experiment, and there is no limit for the dependent variables. We can analyze n number of dependent variables, but we should try to keep the independent variables to a less number. I'll explain why later on. Okay. Now, for an example, if I'm preparing a tablet, I can keep friability, disintegration time, dissolution at a particular time, crushing strength as my dependent variable. I can assess all of them and find out the effect of my independent variables on these dependent variables. So I can keep n number of dependent variables. Only thing is I require to analyze them properly. If you have any question, any query during the explanation, please ask. Okay. Otherwise, I will continue with my pace. Next important terminology is a level. So level is the value which we designate to the factor, which we assign to the factor. We were discussing that disintegrant concentration affects the disintegration time. Now, how much concentration? That is a question. So the answer to this question is called its level. For any experimentation, we require at least minimum 2 levels for designing an experiment. So the lower level and a higher level. Normally, the lower level is designated as -1 level and higher level is designated as a +1 level. So we require, for an example, the concentration I'm using is 3% and 5%. So 3% is my lower level, 5% is my higher level. Normally we try to keep the number of levels below 3, but in some experiments we work at 5 levels as well. Okay, we will discuss this while discussing that experimental design. For binder, for an example, I'm keeping the concentration 4% and 8%. So 4% is my lower level, 8% is my higher level. Clear? Okay, so the assigned value or designation to the factor, it is known as its level. Now, stages of experimental process. How we should progress with our experimentation. So first thing always is the statement of problem. What you are willing to solve. What is your goal? Or which problem you want to address. That is the question. At present, majority of the pharma companies are concerned or working towards the finding out either effective vaccine or the medication for the COVID. Okay, so that is their goal. Moderna has developed mRNA vaccine, Pfizer has developed its vaccine, Serum Biotech, Bharat Biotech, etc. They are all the companies are working. Russian one Russian company, Sputnik 5 vaccine is available. Okay, so all were working with the goal to solve the problem. That problem was to devise to develop the vaccine for the COVID. So that is the statement of the problem. You may have any problem you can solve. And in experimentation, actually, it is a free space. There are no restrictions. And for innovations and experimentation, you should always keep your mind open. Okay, this the common layman or people in South India, they are devising the device, that is the tree climbing apparatus, because coconut tree is very high and they need to climb the coconut tree to collect the coconuts. So they have devised coconut tree climbing apparatus. Okay. Then in some areas where waterlogging is higher, they are devising cycles which can be used on road as well as on water. So that is their innovation, their research. So you first need to identify the problem, and then you need to develop, try to solve that problem. For an example, here we are developing an analytical method based on HPLC. Okay, so that is our problem. That is the statement. Second step is we need to choose the factors to be investigated from that experiment. Which are the factors which affect my experiment, that are to be identified. So, for an example, in HPLC flow rate, then composition of the mobile phase. If you are working with the gradient flow, that is percentage of solvent A or solvent B. This can be considered as a principal factors. There are other factors also which may affect the experiment, like the type of column, whether we are using C8 column or C18 column. Then pH for buffer, if we are using the buffer in a gradient system. Then the lead size, okay, etc., etc. There are a number of factors which affect the HPLC process. Out of that, we need to identify which are the significant factors, and we need to evaluate them. Okay. Then choice of the levels. We have once identified that I will take flow rate and the composition of mobile phase as a factor. Then I need to check at which level I will work. Now, this checking is dependent on either the previous research, that is, it is called prior art, already available literature, or it can be checked by preliminary trials. Okay, preliminary trials, that is, the trials are which are performed to check or get a rough idea. For an example, you are taking a pilot result in your analytical methods. When you are going for titration, first you take a pilot result. Okay, so pilot result is a rough result. You go on adding the titrant without caring much about the end point, but at a faster speed, so that you can come to know that your endpoint will be around this volume. So on next experiment, you can add up to that or somewhat lesser amount very quickly, and you can reduce your time of experimentation. Okay, so that you can get the idea and you can minimize your experimentation time. Here also, using this preliminary trials, you can draw the conclusions and you can select your levels. So here we have selected the level flow rate 1 to 3 ml and the composition 20 to 80% of solvent A. So these are my levels. 1 ml, that is lower level, 3 ml, that is higher level, 20% that is lower level, 80% is the higher level. Okay. Now the number of levels can be either 2 or 3 or any other. For an example, only if I'm working with the 2 levels, the lower level will be 1, higher level will be 3. If I'm working with the 3 levels, the lower level will be 1, middle level will be 2, higher level will be 3. If I'm working with the composition, lower will be 20, higher will be 80, middle will be 50. Okay, so I can use 2 or 3 levels as in an experimentation. And depending on that, you need to devise a design. Next is selection of a suitable response. What you want to assess. As I am working with the HPLC, obviously my retention time will be the response. My HTTP can also be my response. My AUC, area under the curve, may also be my response. But here for the simplicity, I have taken only one variable, that is retention time as a response. Then choice of the experimental design. Now which design is to be used? Depending on the number of factors and number of levels, the designs, full factorial designs can be two level two factor designs, three level two factor designs, and they are normally represented as level raised to factor. Level raised to factor. So here 2 raised to 2 means 2 levels 2 factor design. 3 raised to 2 means 3 level 2 factor design, and it will have the number of experiments like 2 square, that is 4, or 3 square, that is 9. So if I am working with 2 levels, lower level, that is -1, is 1 ml per minute. Higher level, that is +1, is the 3 ml per minute. Okay, if I am working with the three levels, it will be 1 ml, that is -1. Middle level is designated as 0, and that is 2 ml per minute, and higher level, that is 3 ml per minute. Next step is performance of the experiment. We need to perform the experiment in order to collect the data. So we are designing the experiment. Now, while constructing the design, you should construct the design in such a way that all the possible combinations are performed. Okay, all the possible combinations of the experimental runs are studied. So your x1, that is your first factor, is first kept at lower level, and x2 is also kept at lower level. Then you are changing not changing x1, you are keeping x1 at -1, and you are changing x2 to +1. Then 1 -1 and 1 1. So you are having total 4 combinations, and you are performing experiment at all these 4 combinations. Okay. So this is your design, and when you run the experiment, you may end up with the result like the retention time is 5 minutes, 6 minutes, 2 minutes, and 3 minutes. Next step is you need to analyze the data. In order to determine the relationship between your independent variables and dependent variables, you need to you need to analyze the data. Normally the data analysis is carried out using softwares like Microsoft Excel or Design Expert or Minitab or SPSS, etc., etc. There are a number of softwares available which will analyze the results. So you will find out a relationship, an equation, that is called mathematical model, which represents the relationship between your independent variables and dependent variables. Your independent variable y, that is equal to b0. B0 is nothing but the average response, or it is called constant. b1 x1, b2 x2, b12 x1 x2, where b1 and b2 are the coefficients of factor x1 and x2, and b12 is the coefficient of the interaction terms. Interaction term means sometimes the response is not changing to the extent it should change when we are changing both the variables at a time, and some correction is required. So that is called interaction term. Okay. So there are different models which are proposed for the experimentation, like linear models, in which only relationship is between the independent variables and the dependent variables without any exponential terms. Sometimes nonlinear relationships are also there, which will have exponential terms, that is x1 square, x2 square, and a complete model is with the factors and interaction terms. Now last stage is drawing the conclusion. Out of the experimental design which we have performed, we need to draw the conclusion whether the response is directly proportional or indirectly proportional or inversely proportional to the our independent variable, and we need to find out, we need to draw the conclusion, and we need to represent as a mathematical model. Now till now we have completed the experimental design. If you have any question in this, you can ask.